Now let's look at section 1.4 on lines and exponentials. Um, we're going to differentiate between equations, expressions, and what is and is not a solution to an equation. We will model patterns with a constant addition or constant rate of change. And we will also model patterns with a constant percent change or a constant multiplier. And then we will interpret some of these. So a quick recall is that, okay, expressions have variables, numbers, and operations. Oops. And also the equations are expressions with equals in them. Okay. So let's look at example 1. Classify and evaluate. Is 4x plus 5 an expression, equation, or neither? Well, it has a variable, it has some numbers, and it has an operation, so it definitely qualifies as an expression. It does not have an equal, so it is an expression. Evaluate it when x equals 3. So this is just telling you we know the value that this variable is. So variable means it's changing, but now we're saying, no, we know the actual value is 3. So it's not varying, it's staying at 3. So we'll just plug that in because we know that x is really 3. By order of operations, we do the multiplication, then we do the addition. So we get 17. Is 3x minus 7 equals to 2x plus 6 an expression, equation, or neither? Well, has variables, numbers, and operations, so it's an expression. And it also has an equal in it, so it is an equation. Is it true when x equals 3? Well, let's figure that out. So left of equals would be 3 times the value of x is 3 minus 7, which is 9. Take away 7 is 2. Right of equal is 2 times the value of x is 3 plus 6. So that's 6 plus 6 or 12. No. Two does not equal 12. So is it true? No, it is not true when x equals 3. They do not equal each other. Is 4x minus 7, and then we have this symbol, x plus 10, compared to x plus 10, an expression, equation, or neither? Well, it has variables, numbers, and operations, but it doesn't have an equals, and it has another symbol that is not quite an operation, but a relationship of less than. So that right there turns it into an inequality, saying less than or greater than. Is this true when x equals 3? Well, let's plug it in and see what we get. So left, 4 times 3 minus 7 is 12 minus 7, which is 5. And on the right, we would have 3 plus 10, which is 13. And now let's put it in there. So the left was 5. We had the less than symbol, and then the right was 13. Yes. 5 is less than 13. Okay. So even though it wasn't an equation, something could still work and make it true. It did. classify 4 equals 3 plus 1. Okay. It doesn't have variables, but it has numbers and operations. And so we're actually going to give this a slide. So maybe this is an and or, because it doesn't have any variables, but it does classify as an equation. So just to make our language more clear, and it has an equals. Is it true? Yes. 3 plus 1 does indeed equal 4. Okay. Create an equation that is not true. Now you have a lot of liberty here, but I'm just going to choose this one and do something slightly different. 5 equals 3 plus 1. Not true. It is an equation similar to this, but it is not true. Number 6 is evaluate. Okay, so this is kind of like what we did up here. I just want you to get used to this word. Evaluate is kind of like saying, right, replace with a value. So evaluate, in my mind, plug in the known amount. Okay, so let's do that. So 2 times, we know the value of x is -8 minus 7. 2 groups of -8 is -16. A debt of 16, take away 7 is -23. All right, so just a little bit of just classifying and figuring out what's an expression, what's an equation, because you'll see that terminology. Example 2 looks at the price of a chip, not a potato chip. That looks like a computer chip. All right, so I'm looking. Do you notice any patterns in the price for each year that passes? Take a moment, see if you can figure out what's happening consistently. I see a pattern. It's add 5 every time. 2 plus 5 makes 7. 7 plus 5 makes 12. 12 plus 5 makes 17. 17 plus 5 makes 22. 22 plus 5 would be 27. Another year past 2008. 5 years after 2008. Okay, so the pattern, okay, so do you notice any patterns? Yeah, I feel like I noticed a +5 pattern for every year that went by. So let's do that. Yes. Add 5 for each year that passes after 2008. Okay. So use the pattern to write an equation for this situation. Ooh, okay, let's fill in this pattern thing. So it looks like it was, okay, 2 plus 5. And then, okay, so maybe instead of writing it here, I really should have done this because I see that is what's happening. Yeah. And now it says, right, price rewrite. Okay. All right. Well, this is just 2. So this price is 2 plus 0. This is 2 plus 5 makes 7. 2 plus 10 makes 12. 2 plus 15 makes 17. 2 plus 20 makes 22. 2 plus 25 makes 27. And now we can rewrite this, noticing that these are all factors of 5 and we're adding 5 each time. So I would rewrite this. 2 plus 5 added 0 times. 2 plus 5 added 1 time. 2 plus 5 added 2 times. 2 plus 5 added 3 times. 2 plus 5 added 4 times. 2 plus 5 added 5 times. So no years went by, so don't add an additional 5 to the price. 1 year went by, so add $5 to the price. That's what happened here. After 2 years went by, 2 5s have been added, $5 increment, and then another increase of $5 for the price of this chip. Okay, so here's what I see. If I pick something for this, maybe let's call it T for time, and I look at this pattern, right? I would write that the P for price is equal to 2 plus 5 added T times. Okay, so use the pattern to write an equation for this situation. Clearly describe what each variable represents. So I said T equals years since 2008. P is equal to the price. Price of this microchip. That's HIP in dollars. And the equation P equals 2 plus 5 added T times. Use the pattern or the equation to predict the price in 2021. Okay, but this is a year. So I'm going to go back up here and kind of think about this in terms of years. This is 2008. Sorry, not 2000 and late, if you're a Black Eyed Peas fan. Anyway, so that was 2008. 1 year after was 2009, 2010, 2011. So 8 plus 3 years would make 2011. 8 plus 4 years would make 2012. 8 plus 5 years makes 2013. So 2008 plus how much gets us to 2021? Well, let's figure that out. That is 13 years. And so, okay, T is years since 2008. So T is 13. And then we would compute the price. So the price, we know how many years have gone by. So we do 2 plus 5 times 13 years that have gone by. So 5 was added 13 times. That looks like calculator work if I ever saw that. Okay. 2 plus 5 times 13. Got it. 130. So, oh boy, I totally made it. I was like, that doesn't seem right because I was thinking about my pattern. Look, I did times and times. 2 plus 5 times 13. 67. So $67 in 2021. Use the pattern or equation to determine when the price of the chip will be 52 bucks. Okay. There are 2 ways to do this. You could keep going with the table. Just boom, 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 boom. Yeah. And keep adding 5 until you get to 52 in the price. Or I'm going to choose to use the equation. So you could use the table and keep going with it. You could plug in different times, different T's to see when you get 52 out. So you could plug in some T values, or you could solve the equation. You know what? I am going to solve the equation, but either of these is fine for you to do. So when is 2 plus 5 times T equal to 52? Well, that would mean that 5 times T has to be 50 because here's 2 more. So 5 times T needs to be 50. And 5 times what gives 50? Well, 50 divided by 5 is 10. So 5 times 10 gives 50. So what does that mean? 10 years after 2018. So 10 years after 2018, it is in 2018 when that price of that chip was $52. If the price continues to grow like this, will the price ever be $105? Okay, so I'm going to do it this way again. You could continue the table. You could plug in t's, or we could solve. I'm going to go ahead and solve again. So 2 plus 5 added t times, will that be $105? Well, that would mean that 5 times t would have to be 103, because 2 plus 103 is 105. And if I undo this multiplication through division, so 5 times what gives 103? So I'm going to divide 103 by 5. 103 divided by 5, 20.6. Interesting. Okay, well, now here's the big question. That means that would be 20.6 years since 2018. So, I'm sorry, 2008. So 2008 plus, what did we just say? 20.6 would be in the year 2028.6. So 2028.6, what does that mean? So maybe sometime in the year 2028. Or if you wanted to say between 2028 and 2029. Yeah. And that's assuming that this price is kind of continually changing instead of jumping every year. Like every new year, it's boom, 5 more. So this is kind of assuming that this price is sliding up slowly every year consistently. So some students and some, economics, maybe, I don't know, people would say the answer is no, and say, no, it can't be 105 because it jumps annually. Okay, so it will never be exactly 105. It could be 103, or I'm sorry, it could be maybe 102 or 107, but not 105. And that would be at solid 20 or 21 if you did the plug in t values, right? So here's what I mean. 2 plus 5 times 20, I don't need that, is $102 for the price. 2 plus 5 times 21 years later is 107. 105 is in the middle of that, which is kind of why we saw it happen in between. So if you answer yes, you would answer like this. And if you said no, it's a jumping price, then you would actually say no, because it could only be 102 or 107. Just have to be clear about your explanation. What is the explanatory variable? Okay, so explanatory is the independent. So just so that we independent. And the response variable is the dependent. So it responds to the other one. Okay, in this situation. So the question I ask myself is, did the price depend on the time, or does time depend on the price? Well, I kind of feel like time doesn't depend on anything. So, but knowing the price really depended on knowing what year it was. So the response variable in this situation is the price. So the dependent or the response is price. Price depends on time. Uh-oh. Let me turn that off. I'm going to have to stop this video and restart.